Hello everyone. How many times you have faced a situation where you have to write AWS IAM policies from scratch manually? How many times you have bypassed least privilege practices to write IAM policies which are broad in nature, including multiple wildcard characters? I am going to show you a way where you can generate an IAM policy automatically based on your code in a simple and secure manner. By the way, my name is Ramesh Rajan. I am a senior security architect with AWS. In the agenda, I'm going to lay out the problem statement. I'm also going to walk you through the solution. Then I'm going to show you a demo, how I have used an application, used IAM Policy Autopilot MCP server to generate an IAM policy. I will deploy and test it to show you the end result. So every time when we build an application, what permissions that application requires to run successfully becomes an afterthought. Since it becomes an afterthought, we tend to provide more privileges than what the application requires. And most of the time, this building an IAM policy is a manual process. And it can also become very complex depending on what kind of conditional statements that you want to add and the number of services this application interacts with. Here, I have a simple order processing microservice. This service basically accepts an order through an SQS queue. The heart of this service is a Lambda function, which reads from that SQS queue and, commits that order into the DynamoDB table. It also sends an SNS notification for other teams or other microservices to consume. So this Lambda function now requires the least privilege policy because it also interacts with multiple services. The solution I'm going to use here is Kiro. IDE is not something new to us, but Kiro is special because it's an IDE enabled with AI and it has access to large language models. I am going to use a steering file to tell Kiro every time I'm encountering an IAM policy like scenarios, it has to use the IAM Policy Autopilot MCP server. The result of this solution is we will achieve the least privilege policy that we can deploy with our application. Now let's jump into the demo. Before we start the demo, there is a prerequisite. The prerequisite is you have to install the IAM Policy Autopilot MCP server in Kiro. Here I have installed the MCP server in my user config. You can also install the MCP server specific in your workspace config as well. I talked about the order processing microservice. I am going to use CloudFormation to deploy this order processing microservice. The first resource I'm creating in my CloudFormation template is a KMS key. I am going to use this key to encrypt SQS, SNS, and DynamoDB. Then I'm creating the DynamoDB table, the SQS queue, and the SNS topic as part of this CloudFormation template. I also have a dead letter queue, which will act as a catch-all in case of errors in my workflow. The heart of this order processing microservice is my Lambda function. The code for the Lambda function is also within the CloudFormation template. I have a Lambda event source mapping, which will wire the Lambda function to the SQS queue. As you can see in my CloudFormation template, I don't have a Lambda execution role or the associated permissions for that Lambda function. I am going to use Kiro and IAM Policy Autopilot MCP server to scan my CloudFormation template and generate the required policies. Before I do that, here is the second prerequisite. I have to tell my Kiro to use a steering file. So the steering file basically tells Kiro or the LLM that is configured within Kiro to use the MCP server when encountering CloudFormation templates or encountering IAM related tasks or fixing access denied errors. I have pre-created this step, but I will also show you how to create this steering file using prompts within Kiro. Let me open my chat agent. I'm going to use the first prompt, which will say that I will be using IAM Policy Autopilot MCP server to generate IAM policies. Kiro responds back that it will follow the steering file that we created for any IAM related tasks. The second step is I'm going to ask Kiro to analyze the existing CloudFormation template and create a new least privileged IAM policy. So Kiro has analyzed our code and has called the MCP server that we have configured to generate a skeleton IAM policy. And it is asking us to review whether this policy is good. You can see here, there are still some wildcard characters on the resource entries. The reason is we still don't know the resources have been created or the resource exists or not. So this is a skeletal policy. I am only worried about the actions statement in this policy. And I'm good with this policy. I'm going to let Kiro to proceed. So we have attached the role and the policy to our CloudFormation template. Let's deploy this template to the AWS account and then validate if we can create the resources. The order processing microservice has been deployed. Next, we can test the entire workflow with a test payload. Now I'm going to submit a test payload to our order processing microservice to validate the IAM policy and the role that the Lambda function uses to execute is able to complete the entire workflow. I have created a test workflow.sh script to help me in this process. I'm going to submit this to Kiro as a prompt. So this script basically collects the three important details: the queue URL, the name of the DynamoDB table, and the Lambda function. And the next step, it will submit a payload to the SQS queue. The payload is basically order ID, order test with some numbers. And these numbers end with 3899. That's the order ID. Now we are waiting for the Lambda function to process the message. Checking the Lambda execution logs, whether the order was processed. And from the log, it clearly points out the payload is already processed. We also want to verify the order in DynamoDB, which as well, we are able to find the order in DynamoDB as well as a DynamoDB item. The next step is going to verify the message is deleted from SQS, because we have to delete the message from SQS because we have already processed it. And we also got the status, the message has been successfully deleted from the queue. The final step, we are going to see what the role and the IAM policy itself. What are the actions, the role and IAM policy used by the Lambda function? Perfect. So our validation completed. With this, we have created orders processing microservice. And along with that, we used IAM Policy Autopilot MCP server to generate a least privilege policy. And we have also tested this entire workflow by submitting a payload to validate if our policy works. So what you just saw is I am moving from a static manual control to an adaptive intent-driven system. Developers declare their intent, and IAM Policy Autopilot MCP server generates the least privilege policy automatically. For developers, nothing changed, and that's the point. There is no IAM, there is no JSON, there is no ticket queues, and they're also not waiting for security teams to build the right policy. This is policy orchestration at runtime security, and it scales with your business. And from a security perspective, this eliminates three chronic problems: over permission roles, permission drifts, and standing permissions. Every permission is purpose built, scoped to intent, and fully auditable. With IAM Policy Autopilot MCP server, developers benefit from increased velocity of developing applications and delivering features to the organization. It also results in reduced friction in operating in a cloud environment, while security teams massively gain from increased security posture because of the use of least privileged permissions in the environment. I hope you found this video helpful. Thank you.